Hi, I'm Tandy Dang from UCR RoboSub, and joining me is,
Dmitry Koltsov.
and we're going to talk about hull design today for our thruster control layout. In our previous 2019 Sea Dragon design, we took a straightforward approach to building our hull or chassis. The submarine only needed forward and backward translational movement in addition to being able to ascend and descend in the competition pool. The only rotations that we required were clockwise and counterclockwise yaw to face in a given direction. In the 2021 Leviathan design, we built upon the previous model by incorporating all of the older movement directions, and then adding the additional strafing axis of translation. Now, our robotic submarine can also move left and right without the need to turn. This improvement required a redesign, changing not only the chassis but also the thruster layout. We increased the total count of thrusters from 6 to 8 in this iteration, to account for all directional movement. Although all three axes of rotation, pitch, roll, and yaw, are supported by the Leviathan redesign, only the yaw rotation is used in practice. This is because pitch and roll are automatically managed by our PID software to maintain balance in an upright position.
In order to operate our thrusters, we send signal to each thruster, and for signals above certain threshold, we consider them to have positive values. For signals below the threshold, we consider them to have negative values. We send signals with positive or negative values to each thruster to thrust in the desired direction. This causes the entire submarine to move in the desired direction along the current axis.
The strategy for competition this year was to have a stable, robust, and modular system, capable of adapting to our needs over a lifetime of several years to come. This three-chamber design was expanded upon by the previous two-chamber design, which was actually just a main chamber and a separate battery pod. Fortunately for us, the simple design choice to separate the battery pod saved us from a potential disaster when performing a live water test on the previous model. More on this later. Apart from the battery chamber, there is also the main electronics chamber in the center, which houses a removable electronics rack for easy accessibility during maintenance and testing. This was aimed at significantly speeding up our testing cycles so that development could progress more quickly in general, and also during on-site tuning. The third chamber is reserved for pneumatics, housing our torpedo for any projectile tasks. A quick release mechanism holds this torpedo in place until it is electronically signaled to fire. In the forward axis, our thrusters will move in either the red or the blue direction in order for the entire submarine to move forward or backwards. In the strafing axis, we have our thrusters moving in either the red or blue direction, and in this orientation, the entire submarine moves either left or right. In the yaw axis, our thrusters will again move in the red or blue direction, and this causes the entire submarine to either rotate clockwise or counterclockwise. And finally, we have a comparison of the T100 and T200 thrusters from Blue Robotics, which this submarine uses. We can see that based on the variable PWM input signal values, we have a certain amount of thrust for each thruster. Each thruster has its own direction in the previously shown red and blue directions in order for the entire submarine to move along a desired axis. For safety reasons, we have a common range of 1,200 to 1,800 for PWM values. This makes 1,500 the common zero thrust value threshold for all thrusters. During a live water test on the previous Sea Dragon model, we encountered a very unexpected problem.
Killed.
What's that light for?
Yeah, why is it orange light?
That's a fire!
The main chamber caught on fire from an electrical short circuit due to high currents from the thrusters, caused by a failure in the kill switch. This prompted us to maintain the design of keeping a separate chamber for the batteries, which are technically explosive.